All right, let's do this. Last one of the chapter. I know, this little short chapter, there's only 5 of them, but this is it for this chapter. So, kickoff, we're going to do the inverse and contrapositive. So if we have the statement, if it is geometry class, then Mr. Weasley is the teacher, we would write for the inverse, if it is not geometry class, then Mr. Weasley is not the teacher. Inverse, so we negate the hypothesis and the conclusion. So we negate the if, negate the then. The contrapositive, we're going to switch them and negate them. So if Mr. Weasley is not the teacher, then it is not geometry class. Excuse me. So, inverse, just negate the if and the then. The converse, we negate them, plus we switch them, so they're in the opposite order. Now, getting away from writing these things, we're going to look at the comparison property of equality. So, if we know that A equals B plus C, so A is going to equal 2 things added together. And if we know that C is greater than 0, so it can't be a negative, that would throw this off, well, then we know A has to be bigger than B, which makes sense because if we're adding 2 things together, it would be bigger than either one of the other things that aren't added together. So A is equal to B and C, so if C is not there, then A should be bigger than B. Now, we're going to prove this with a 2-column proof. Starting with always are given, so let's circle it, draw the arrow down. So we're given that statement. Well, one thing we would know is that B then would be equal to B. They're both the same variable. So if we add C to it, and we know that C is greater than 0, it should make it bigger than if we add 0 here. So if we take B plus C, that should be bigger than B plus 0 because we know that C is greater than 0. So C has to be bigger. So if we're adding C to it rather than a 0, this side should be the bigger side. Now, we know, and this is going to be just the addition property. Now, anything added to 0 is just going to be itself, so we could say that B plus C has to be bigger than B. And all we did there was just simplify. Well, we also know that A is equal to B plus C, so if we have B plus C, we could sub that out and put A in by substitution. Okay, so if we both have B's, they would be equal. If we add C in, well, now this side should be bigger. And if we add 0, that still should be bigger because we know C is bigger than 0. So if we simplify this and get rid of the plus 0 because B plus 0 is still just B, we could then sub in A for the B plus C because we know that's equal and show that A is greater than B. So we just showed that inequality. Now, using this property, we can add on a corollary to theorem 313, the triangle exterior angle theorem, which if we look at a triangle exterior angle here, so if this here is one that you can kind of see there, this exterior angle, so the measure of angle 1 would equal the measure of angle 2 plus the measure of angle 3. So the outside angle here would be equal to the 2 inside angles away from it added together. That's what theorem 313 is saying. That's that triangle exterior angle theorem. Now our corollary is going to say that, hey, if we know the measure of the exterior angle is greater than the measure of each of its remote interior angles with this corollary. So if 1 is our exterior angle, it's going to be bigger than 2. 1 will also be bigger than 3, which again makes sense because 2 and 3 added together equal 1. So 1 should be bigger than just one of them by itself. Now, in this figure, we're going to know that 1 and 2 are equal. So we could have this be congruent to this one. Those are both the same. Why would 2 be bigger than 3? Well, we're looking at this. Well, 2 is an exterior angle compared to this, but these aren't the remote interior angles. However, 1 would be the exterior angle of these two being remote. So we could say that the measure of angle 1 is going to be bigger than the measure of angle 3. Because 1, the exterior angle, should be bigger than its interior angle of one of the remote interior angles. Because both those added together equal the outside. Well, this is by that corollary. Well, we could then say that the measure of angle 2 would be bigger than the measure of angle 3, since 1 and 2 are congruent, so this is through substitution. All right. Next, theorem 510. So if two sides of a triangle are not congruent, then the larger angle will lie opposite of the largest side. So what this is saying is if XZ here is the largest side, Y then would have to be the largest angle. So opposites there, so the largest side always opposite the largest angle. So medium side opposite of median angle, small side opposite of the smallest angle. That's how that's going to work. So if we have a landscape architect that's going to place benches in the two larger corners, which corners does she want to use? So which ones are going to be the largest angles? Well, this is C over here in case you can't see it. It's cut off there. But looking at this, 27 feet is the longest side. So AC is going to be the longest side. So opposite of that would be angle B. So I'm going to go to my next longest side. Well, 21 is bigger than 18, so 21 is my next largest side. Opposite of the 21 is angle C. So those would be the two sides I'd want to build a bench for that deck. Okay. Now, theorem 511 is just saying the opposite. It's really just the converse of it. So if we know that, so as long as so if the two angles of a triangle are not congruent, so as long as the angles are different, then the longest side will be opposite of the largest angle. So it's just saying it backwards. If we know this is the largest side, the other one's got to be the opposite's the largest angle. That was 510. 511 here is saying, hey, if this is the largest angle, then this has to be the largest side opposite of it. Now we're going to prove this with an indirect proof. So looking at this, we're going to start by saying assume. Well, we're proving that BC is bigger than AC. So opposite of that would say BC would be less than or equal to AC. Because the opposite of being bigger would be either equal or smaller. We always want to have just two options instead of the three. So we put the two together. So knowing that that's bigger, we would say then, or I should say assuming that's bigger, well, the given says that A should be bigger than B. Well, if it's the other way around, if BC is bigger, then the measure of angle A should be less than or equal to the measure of angle B. Which again is our contradiction because we were given that A is bigger. So therefore, BC has to be bigger than AC. Again, indirect proof, they're actually pretty nice. Now, we're going to take this triangle and we're going to list the sides in order from shortest to longest. So looking at this, I have this angle, I'm missing my third angle. Well, if I know I have two of these, all three have to be 180, so 180 minus 40 is 140, sorry. 180 minus 40 is 140. Minus another 60 leaves me with 80 degrees left here. So if we're doing the shortest side, the shortest angle is X. Opposite of X would be YZ. So my next biggest angle would be Z, so opposite of it would be XY. And lastly, Y is my biggest angle at 80, so opposite of it would be XZ. So it would be my longest side. So shortest to longest is how that would flow. Now, something to keep in mind is not all side combinations will work. While 3, 3, 5 works, a 2, 2, 6 will not work. If you think about it, even if we laid these down flat, the two sides wouldn't reach each other and we'd have an open shape, which wouldn't be a triangle. So with that, we have theorem 512, which is the triangle inequality theorem. So in order for this triangle to work, the sum of the lengths of any two sides of a triangle have to be greater than the length of the third side. So if I add these two together, it has to be bigger than the third. If I add these two, it has to be bigger than the third. If I add these two, it has to be bigger than the third. So any two sides added together have to be bigger than the third side for it to be a triangle. So could we have lengths of 3, 7, and 8? Well, 3 plus 7 is 10, which is bigger than 8. 3 and 8 is 11, which is bigger than 7. And 7 plus 8 is 15, which is bigger than 3. So yes, this works. Here, 3 plus 6 is 9. That is not bigger than 10. So this one would not. Now, you may ask, well, what if there's two that are the same? So if it was a 3, 3, 6. Well, 3 and 3 would add together to be 6. That would be equal. But it's not bigger. It has to be bigger. It cannot be equal. This still does not work. All you would get is a straight line there. Because if this is 6, you're 3 in, you'd be at the middle. You'd have to be on that line to make that work. Still not a triangle, so it doesn't work. Now, well, what happens if you're missing a side? Well, we can use this to kind of narrow down what our side length could be for that third one. So we have side lengths of 8 and 10, and since we don't know our third one, we're going to call it x. So if we add any two together, so if I take 8 plus x, that has to be bigger than 10. If I do x plus 10, that has to be bigger than 8. So then lastly, if I do 8 plus my 10, that has to be bigger than x. So any two sides have to be bigger than the third. So you're going to make these three inequalities. And then we're going to solve them for x. So here we would subtract the 8 over, and so x has to be bigger than 2. Here we would subtract the 10 over, so x would have to be bigger than negative 2. If we add these together, we get 18 is bigger than x. So in other words, if we flip this, x would be less than 18. So we kind of have our boundaries. If we looked at this on a number line, we'd be here at negative 2, at 2, and then at 18. So my 18 would be an open circle, and it would cover everything here to the left. My 2 would be an open circle, and it would cover everything to the right of that. Negative 2 would also be an open circle, and it would cover everything to the right of that as well. So what we want to have is the spot where all three equations work. So 18 is the biggest it could be. 2 is where the overlap stop for all three, because that's where this one stops. We'd only have 2 of them going here. We have to have all three. So the overlap is just going to be from 2 to 18. So we're going to write 2 is less than x, which is less than 18. And that's how you solve those. So, have any questions, please let me know. You can always pan me, email me, send me a message on Google Classroom. Remember, you can always pause and rewind and watch something. You can pause it, write something down if I went too fast. But until next time, we'll talk to you later, guys.